starting the recording now, starting of the YouTube videos. I might be able to find some other better videos and might share you those links in our messenger group chat in due time, which are very easily accessible if you know how to access those things. That is, if you go into the messenger group chat from your laptop or from your PC device, you will have this group chat window, and over here you have all the stuffs. What you don't have is the shared links. এখানে shared links আসার কথা না?
হ্যাঁ স্যার,
আসে?
লাস্ট টাইম যখন গেছিলাম তখন তো আসছিল।
না, এটা তো shared files. shared links কি আসে?
আচ্ছা না, লিংকস আছে না, লিংকস আছে না।
ব্যাড। আচ্ছা, ব্যাপার না। আচ্ছা দেখো, আমি কি বলতেছি খেয়াল করো। আমি বুঝাই দিচ্ছি ক্যাপাসিটরের মধ্যে কি কাপচাপ আছে। আমি কিছু আগে টার্মিনোলজি বুঝাই, তারপর আমি আস্তে ধীরে ইকুয়েশনস গুলো বুঝাবো। So our note existed in this folder. That's notes. There were. So this is the circuit symbol for a capacitor, which is basically two parallel lines of equal length. Hypothetically, you can assume the capacitor to be consisted of two metal plates facing each other at some distance from each other, so that there might exist an insulator medium in between, or this place can be also a vacuum or empty space, or it can be also air. Air is also a medium. So it is possible that the in-between space might have something. It is possible that the in-between space might not have something. And this much is the circuit symbol for a capacitor. And in this figure, we are trying to show you that this capacitor is gonna be charged using this source. So currently we are assuming that this capacitor is discharged state, which means there is no charge difference across these two plates. One of the key information that I'd like all of you to understand, very important, that is, capacitor does not store charge. Capacitor practically stores energy. Capacitor is just a much more, what can I say, simplified version of sort of like a battery. The difference is that any battery stores the electrical energy. I mean, it gives out electrical energy, but the stored form of energy in a battery is essentially in chemical form. Whereas in capacitors, the electrical energy gets stored in electrical energy form. It doesn't convert to another energy form. So how does that get stored in the electrical energy form? That I'm going to cover after a while. But what is really important for you to understand that, let's say this is a plate, I mean, this is a metal plate, and if we now close this switch, in this circuit I haven't shown any resistor. So let's assume that this battery has some internal resistor, because if there is no resistor, there would be infinite current for an ideal battery and for an ideal capacitor. So that would be difficult for us to explain or to comprehend as well. So assume that the battery has some internal resistance, so the current flow that is going to happen in this circuit is not going to be extremely high to cause burn up or some other troubles. So whenever we close this switch, current will start to flow. Now you might wonder, why should current flow? There is no continuation of this wire over here. This wire is disconnected, so why should the current flow? The reason the current will flow, because these two lines, A and B, they are designated as two metal plates. So these two are considered as two metal plates. Being metal plates, they have quite a good amount of reservoir of electrons, and simultaneously, which essentially mean that you can take some significant number of electrons out of them, making them positively charged, or you can also push certain number of electrons into them, making this plate negatively charged. You can do either of them, and they are going to be accepting that process as long as it is made to happen. Now, what does it mean by saying that as long as it is made to happen? What do I mean by this? It means that the capacitor will necessarily, like every object, will prefer to be at neutral state. If you cause it to become charged, then it will have some charge, but it will try to become discharged the first chance it gets. The idea is very simple, that every object preferably come to zero potential. So if we do charge any of these plates, A or B, they're gonna try to come to zero voltage in the first chance they get. So what are the things that can happen? Let's try and understand. Whenever we'll close this switch, this positive end of the battery is gonna try to suck up on electron. It's gonna try to absorb electron because this is the positive end of the battery. Whereas this is the negative end of the battery, this is gonna try to push out electrons. So this side of the battery is going to cause the electrons to flow through this path, and B is gonna start to become negatively charged over time, and A is gonna start losing electron because of the attraction of this positive plate, and electrons are gonna flow in this manner. So this is how the currents will flow. Current will start to flow, but it will not continue for a really long duration.
So it will repeat for them.
Electrons are going to be released from the negative side of the battery, which are going to push to the plate B, and electrons are going to start getting lost from plate A, which is going to get absorbed by the positive end of the battery. So whenever this process will start, at the initial time, if let's say the incident of time when the switch was closed was t equals to 0, at that point the two plates were perfectly neutral, which means each of the plate had equal number of protons and neutrons by count. But whenever the capacitors is going to start getting charged, or we're going to start charging this one in negative charge and this one in positive charge, over the time, the amount of positive charge in this plate is going to start to increase because more and more electrons would get lost. And this plate is going to become more and more negatively charged. One of the important bit that you really need to understand that on a regular case, capacitor is going to work in a very similar way like a battery works. You have to understand that batteries always work in such a way that the number of electrons that is given out from the negative end is the exact same number of electrons that come and have to enter to the positive end. You cannot simply take out electrons out of the negative end of a battery and not allow electrons to the positive end. In that scenario, a battery will never give you electrons. You have to complete the circuit. The battery is not gonna become charged. What do I mean by the battery is not charged? The entire point of having a battery is auto charge. Try to understand. Battery is basically like an electron pump, sort of. Inside the battery, we have some sort of chemical reaction which continuously pushes the electrons that exist inside the battery from one plate to other plate. The left plate for this figure, this is the positive plate, which means by the chemical reaction that is happening inside this battery, electrons are continuously being pushed to the right. So that chemical reaction is not essentially causing the battery to permanently lose electrons. It is continuously trying to push the electrons to one side. But if you at any point take out 10 electrons out of this negative end, you have to also feed 10 electrons to the positive end as well. The entire battery in electrostatic sense would always maintain equal number of protons and electrons altogether. But because of the chemical reaction, it is gonna always also it will also maintain a difference of net charge amount on the two opposite side of the battery, which means one plate would have redundance of electron, the other plate would have exactly equal number of shortage of electrons. But the total number of protons inside a battery and the total number of electrons inside a battery will always be exactly same. That's how a battery operates. Capacitor is no different. Capacitor, the way capacitor works is that whenever plate B is gonna start accepting electrons, plate A will start to lose electrons. And at any given time, if plate B receives, let's say 100 electrons, plate A should also give up exactly 100 electrons, so that the total number of electrons in the capacitor is not one of the plates. Try to understand this entire thing, this whole thing is what makes the capacitor. Together, this thing makes the capacitor. So if you consider that whenever electrons are entering over here and electrons are going out over here, at any given time, the total number of electrons is basically remaining the same. All that difference is happening is that one side is becoming more negatively charged and the opposite side is becoming more positively charged. This is very important information because this will be required for a lot of mathematical understanding down the road. So remember this, capacitor's plate would never give up or accept unequal number of electrons or unequal amount of charge. which means at any case, if this negative plate becomes minus 10 coulomb, the positive charge plate should also have plus 10 coulomb. This is going to happen at any point. I mean, whatever the value that you give over here as negative, the positive plate should also have exactly equal a magnitude of charge, but only in the opposite polarity. So this is why we can say that at any point of operation, the capacitor is practically always neutral, because it does not essentially suffer from shortage of electrons altogether, or it does not suffer from, it does not have redundance of electrons altogether. All that is happening, the electrons are getting shifted from one side to other side. So this is one of the reasons that on the theoretical questions that come in your syllabus is that capacitors do not store charge, they store energy. Explain why. Capacitors do not store charge because the amount of positive and negative charge on the two opposite plates are exactly equal. So at any instant of time, if you calculate the total number of electrons available in both the plates and total number of protons available in both the plates, both of those numbers would be exactly equal. So the total charge in a capacitor will always be 0. This is a very important information. So if that's the case, then whenever we say that, let's say if you make a statement, let's say a capacitor is currently holding Q coulomb charge, or the charge stored in a capacitor is Q. In many cases, we're going to come across this statement. This is a very usual statement. It's not wrong. If we say that a capacitor is now have a charge of Q amount, that is Q coulomb or Q millicoulomb, microcoulomb, megacoulomb, whatever, Q coulomb, that essentially means what is the magnitude of charge in one of those plates, not on both the plates. Combined on both the plates, the total charge will always be 0. What I mean is that if in this capacitor, let's say this plate has a charge of, let's say, minus Q, logically this plate should also have a charge of plus Q. I would say that the charge stored in this capacitor is Q. This essentially represents the magnitude of charge in either of these plates, not both of the plates. So that is a very important information. This Q is a measure of deviation of electron numbers from neutral scenario. So you either have a certain number of electron excess, or you have a certain number of, or you have equal number of electrons additional, which is giving you equal magnitude of charge on both the plates, but one plate has become negatively charged, the other plate has become positively charged. That's one part. If you have questions, raise your hand and leave it at that. I'll take your questions after a while. Let me go through a certain part. So how the current flow will essentially happen over here. Okay, let's say for the sake of easy understanding, let me just draw a resistor over here, because I'm feeling really uncomfortable without having a resistor over here. I should have drawn a resistor over here. I'm pretty sure that I did not draw this resistor in the actual board, so that's why this kid did not copy it. But for the timing, let's say we have given a resistor over here. Why do we need a resistor? To limit the current. Now let's say this is a battery and we have a resistor over here. Let's say that it has a value of resistance R, and we are going to close the switch. The moment we're going to close the switch, this capacitor is going to slowly start to become charged. Now try to understand. Let's have a look. Let's say this source has a voltage of, let's say, 12 volt. Now having a 12 volt source, it would mean that it has a total amount of 12 volt potential difference across the two terminal ends of the battery. Whenever the charge is going to start to flow through, these two opposite plates are going to slowly build up their voltage across them, because this is becoming more negative charge, more negative volts. So this is becoming more positively charged, which means, let's say, after some time, starting from neutral, this plate can become, let's say, plus 2 volt. And logic tells us that at that same time, this plate should become, sorry, plus 2 volt now, my bad. If the right plate becomes, let me use a deeper color. If this right plate has a voltage of, let's say, minus 2 volt, this plate should have a voltage of plus 2 volt. This should happen. Well, in this case, the total voltage difference across the two plates is 4 volts, and the total voltage available across the battery was 12 volts. So these two voltages can slowly start to increase, and at any point we can try. Let's say if I do connect a voltmeter over here, exclusively across the capacitor. Should I connect a voltmeter over here? I can connect a voltmeter over here. Okay, let's say I'm going to connect a voltmeter over here. What's going to happen? Before we close the switch, this voltmeter is going to read as 0, because there is no charge across these two plates and there is no voltage available across these two plates. Once we close the switch, charges are going to flow and the opposite plates are going to slowly become charged. and the voltage across them is going to start to increase. What you need to see very carefully, that this left side, and as this right side plate is becoming more negatively charged, this positive side is going to become more positively charged. Now try to understand this scenario. If I just copy this part on a different scenario on the left side, let's say somewhere over here, I'm going to use, let's say, black. Think about it. If you have a capacitor that is charged in this manner, oh yeah, I have to shift myself. So let's say this is a positive charge battery, this is a negative charge battery. If you have a closed pathway through which electrons can flow through, if you do have a closed pathway, what would be the natural tendency of this capacitor be? It should necessarily try to become neutral, because that's what every object tries to become. In the effort to become neutral, this will try to push out its electrons in this direction. So electrons are going to try to come out through this way, so they can close this pathway, and eventually the capacitor can become neutral. Or in other words, if I say that conventional current would be coming out of this battery in this direction, conventional current, which is opposite to the electron flow, conventional current should be I mean, the capacitor should try to produce a current of its own in this direction. Now the question is, will this capacitor also try to do that? The answer is yes. As the capacitor's voltage across the two plates slowly start to get bigger and bigger and bigger, this will try to produce a current of its own. But will it be able to produce that current? That answer is no. Let me elaborate what I mean. Let's say the voltage of this source is 12 volt. What do I mean by a 12 volt supply? A 12 volt supply essentially means that the amount of chemical energy that we have stored over here can be considered to be of such high amount that even if we take out a lot of electrons over here, feed a lot of number of electrons over here, this battery will be able to maintain 12 volt voltage difference across its two plates. That's the significance of the word battery or cell.
So can you repeat?
Yes, I will. The significant a battery having a voltage of 12 volt means that no matter how much you drain it, for an ideal case or for a discussion purpose, that is, I mean, the amount of chemical energy that is stored within this battery is big enough that by removing a significant number of electrons out of the negative plate and eventually feeding a significant number of electrons to the positive plate would not essentially reduce this voltage amount. If you wonder what does that even mean, here is what it means. Let's say voltage, the definition of voltage is given by what? Energy per charge. So if I say that the source that this battery has a total amount of voltage of 12 volt, then to maintain a 12 volt voltage difference across the two plates, it should have a certain amount of energy stored within the battery that should be relevant to certain amount of charge difference across the two plates. The idea is that if you move around a certain portion of this charge, take it out from the negative end and eventually push it to the positive end, even so, this battery would be able to maintain 12 volt. This is basically how every battery is designed. That for its useful life, it will be able to give you a fixed amount of voltage. Whenever the battery is losing its capability, or we say the battery has gone, the battery has is going down, that's when the chemical energy content inside the battery becomes so low that it cannot give you 12 volt anymore, or the rated voltage anymore. That's when the capacity, that's when the voltage starts to become lowered and the battery becomes unusable. The reason battery becomes unusable because every electrical device is designed to operate at a certain feed voltage or source voltage. For example, if you have some LED, they're going to work at some voltage. If you have a remote control, that's going to work at certain voltage. If you have a remote control car, or if you have a drone, they all electrical devices will work at a certain amount of voltage. They're designed to work at a certain voltage. You can divide that voltage into multiple different parts for your different components, but the rating voltage is a very important factor, which means the source from which energy would be drained, that has to be able to provide energy at that voltage rating for a significant duration of time. That's where batteries come in handy, because batteries can do that. Batteries are designed to perform that way. So what is important for us to, the reason I'm telling you this part, because what I want all of you to understand that even when we are taking out significant number of electrons out of this plate and eventually pushing it to the B plate, and taking significant number of equal number of electrons out of the A plate and pushing it to the positive end of the battery, the total voltage of the battery, 12 volt, will remain 12 volt. That's the point that I'm trying to get across. But even though the battery voltage would remain same, the capacitor's voltage would not remain same, because the two opposite plates are becoming positively charged and positive and negatively charged. So this voltmeter is going to start giving us some reading. From 0 volt, this reading is going to slowly start to increase, because as more charge gets stored in the two opposite plates, this voltmeter reading should start to increase and increase and increase. The question is, what is the maximum value of the value of this voltmeter that can happen? What could be the maximum voltage? Now here's the deal. I want you to understand and appreciate this information. Charge flow happens due to voltage. In the same way, liquid flow happens due to height. Do you understand what it means? That charge flow happens due to voltage. What I'm trying to-
potential difference বোঝাচ্ছে
Exactly.
Charge.
Charge will always happen, charge flow will always happen, or current will always happen, so that a pre-existing potential difference can be minimized. Electrons will always flow so that they can minimize a pre-existing potential difference. That's the basic idea of current.
Like trying to reach an equilibrium.
Exactly, trying to reach an equilibrium, or more specifically, trying to give everything, to make everything neutral. That's the basic idea. So its charge flow is not dependent on the amount of charge of an object. It is dependent on the voltage of an object. If I give you a certain example, let's say if I zoom it out a little bit, let's say if you consider an object, let's say we have a metal sphere over here. Let's say this metal sphere has 10 billion electrons, and of course 10 billion electrons as well. Let's say we have another metal sphere over here which has 10,000 electrons. Okay, but if somehow by process of induction or charging or something, let's say the voltage at the surface of this plate, we have brought it to be, let's say, plus 10 volt, whereas this one was charged to become, let's say, plus 2 volt. Which one is more positive? Between these two, which one is more positive? Or in other words, which one is suffering from a bigger deficiency of electrons?
Left side এটা
Left side. Why am I asking you this? Because if we now connect these two things with a piece of wire, electrons are gonna flow from their apparent saturation case to the lower saturation case. When electrons are gonna flow in this direction, what I need to understand, the total number of electrons over here is more, total number of electrons over here is less, but this amount really does not matter in which direction the current will flow. What it really depends upon is the value of the voltage. Electrons are going to flow as that this one's voltage become higher and this one's voltage becomes smaller, and eventually, let's say, ultimately the voltage becomes fixed at, let's say, this one becomes plus 8 volt and this one also becomes plus 8 volt. I'm just assuming these two numbers, that this one is a large object, so even by absorbing a big number of electrons, its voltage is not going to change that much. That's a basic assumption. So whenever their voltages are going to become equal, that's when the current flow will stop. So current flow is not dependent upon the amount or number of electrons available to an object. Current flow is dependent, or charge flow happens due to the voltage difference. So it's about a relative idea. I mean, one of the similar idea that I can give you, that let's say you have two container, one is small and let's say another one is large. If you connect them by a pipe, in which direction should water flow across them is not dependent upon how much water they are holding. It's going to be dependent which one is located at a higher height. For example, if I locate the small container over here and the large container over here, and if they are connected through a pipe system, no matter, irrespective of the amount of water is always going to flow from here to here, because it's the height difference of the two containers that defines in which direction the water will flow. It's not the absolute amount of water that determines in which direction the water will flow. In the same way, charge flow is determined by the voltage value of objects. So if you have a bigger voltage difference, then it will have a tendency to become neutral, more strong, and that will try to direct the voltage value. Why am I telling you this? It's a very simple idea which we have covered in our AS level as well. You should know this example that, let's say if we connect a battery, so let me just rub this off. We don't need that. And a bit thicker line. Let's say if we have a battery, try to remember that, let's say we have ideal cells of this much. Let's say each of these cell has a voltage of 2 volt. If we connect a bulb in this fashion, the available voltage across this bulb is going to be 4 volt, which makes sense. But if we have a bulb that is connected across a battery, across a combination of battery, that looks like this. How much would be the total voltage available to this bulb? What would be the total voltage available to this bulb?
2 volts.
No, have a look. Have a good look. I did not revert the polarity. The polarities are exactly the same. Plus, minus, plus, minus.
Sir,
Yes.
5 volts.
No, each of the
10
cell
volts.
has 2 volts.
10 volts. 10
How many
volts.
cells do you have? 1,
Five.
2, 3, 4, 5. I mean 4, 5.
Oh, that's sir, 10 volts.
So the available voltage over here, this bulb was 4 volt. The available voltage over here was 10 volt. What if I reverse this source? What if I reverse this source? Then what's gonna happen?
Then it's gonna be 2 volts.
Exactly. Then the available voltage to the source is gonna be 2 volts. So what is actually happening? I mean, why should that be 2 volts? I mean, let me just draw this up. So this is this, and let's say I'm gonna add 3 over here, and then the reverse 2 over here. Good. So if you connect a battery system like this, in this case, the total amount of voltage available to this bulb is going to be only 2 volt, where this is going to be the positive side, this is going to be the negative side. What is happening? This battery is overpowering the effect of this battery. So this battery has a total potential of 6 volt, that is positive on this side, and this battery is having a potential of 4 volt, that is positive on this side. Because they are connected in the reverse polarity, that if we do the total sum of total EMF, we might actually have to subtract them. That way we get plus 2 volt on the left, which means for the entire combination over here, if we consider this entire combination as a certain combination of battery, this left side will be the positive end, this right side will be the negative end. Because the total voltage available output voltage of this combination is not going to be determined by the singular effect of any of these batteries. It's going to be an expression by the combined effect of both of these batteries together. Now, why am I telling you this? That we have to do a subtraction over here. This idea is very much going to be useful for us for this capacitor case. This is actually a pretty small figure. I would prefer to actually redraw this figure over here for a bit easier discussion. Let's say I'm gonna use black. So capacitor, battery, a small resistor, switch, and circuit is complete. Plate A, plate B. কি বলতেছিলাম জানো? আচ্ছা, কি বলতেছিলাম সেটা একটু পরে বলতেছি। I'm gonna further আচ্ছা না, আমি আর একটু বলে নিই, তারপর তোমাদের কোশ্চেন এসে। Hold up a second. Let's say in this condition, this battery, I assume this battery to be 12 volt, okay? And the moment we're going to close the switch, current is going to start to flow. So initially the voltmeter reading that we had connected across the capacitor, this voltmeter reading was supposed to be 0 volt. As time goes further, this voltmeter reading will increase to how much? The supply voltage that you are feeding this capacitor from is 12 volt. So the maximum voltage that this capacitor can gain is also 12 volt, because you cannot essentially make an object have a potential bigger than its original value. একটা ব্যাটারি ইউজ করে, একটা 12 ভোল্টের ব্যাটারি ইউজ করে আমরা একটা ক্যাপাসিটরকে 12 ভোল্টের বেশি ভোল্টেজ দিতে পারবো না। কেন দিতে পারবো না সেটা আমি এক্সপ্লেইন করতেছি। যত as I mean the further this capacitor become charged, this side is going to become positively charged and this side is going to become negatively charged. Let's say at certain point that voltage, this voltmeter reading is, let's say 3 volt. This 3 volt means what? This 3 volt means that now the capacitor has a total voltage of plus 3 on the left side and minus 3 on the right side. So no, not necessarily plus 3 minus 3. The total voltage across the total capacitor is 3 volt. And now have a look. This battery is trying to produce a current by its own polarity in this direction, clockwise direction. The battery is trying to produce a current flow in this direction. Whereas the capacitor, to be able to become discharged, is actually trying to produce a current in the reverse direction. This is the exact same thing what we discussed in this circuit. For example, over here, this set of battery was trying to produce a current along this alignment, but this small set of battery are going to try to produce their own current in this alignment because of their basic polarity direction. But this battery cannot do that because there is a much stronger battery, much stronger potential provider that is connected in the reverse order. So this will become minor, or this will become succumbed into the process, and this is going to continuously provide an opposition towards the effectiveness of this battery. That's why the total EMF of this entire source is becoming 2 volt. This source is not going to work as a 10 volt source. This is going to work as a 2 volt source, because I mean, if I go for a much more detailed idea, if you bring out 1 coulomb charge out of this side, let's say this 1 coulomb charge, let's say, starts with X joule amount of energy. I'm choosing the X intentionally. Let's say this 1 coulomb charge starts with X joule. As it's going to pass through the bulb, and it's going to lose some part of this energy. Let's say this, I said that over here the voltage was 2. So by passing through the battery, this 1 coulomb charge is going to have a remaining amount of energy. Let's say when this 1 coulomb charge reaches to this point, it's going to have a total amount of energy of X minus 2 joule. Because 2 joule would be lost over here. 2 volt means 2 joule per coulomb. This bulb is going to be utilizing 2 joule of energy, extracting that out from every coulomb of charge that passes through this bulb. As this passes through over here, now have a look. This battery now, this 1 coulomb of charge now have to go against their preferable direction. They have to now travel from the positive end to the negative end, which means as they were going to pass through this battery, they will also have to go through a total amount of voltage that is going to eat up 4 joule out of their own amount of energy. So it started with X joule of amount of energy. It lost 2 joule over here, and then as it passes through this one, this thing is not going to help this charge to pass through. Rather, this is going to try to absorb more energy out of it, because now the current is flowing through this battery in the reverse order, which basically is the base process to charging up this battery, which we've learned in the Kirchhoff's law process in our AS syllabus. So it was a relevant discussion there, which means whenever this 1 coulomb charge is going to reach up to this point, at this point, the amount of energy of this 1 coulomb charge is going to be X minus 6 joule. So, and it will enter into this battery. So have a look exactly how much joule of energy is actually provided from this source. This source is providing exactly 6 joule of energy. Each coulomb of energy was coming out of this battery with, let's say, X joule, and ultimately they're entering back into the battery with a total amount of energy of X minus 6 joule. So each coulomb of energy, each coulomb of charge, 1 coulomb of charge is actually spending a total of 6 joule of energy that is provided from this source. 6 joule from this 6 joule, 2 joule is being used by the bulb, and 4 joule is eaten up by this battery, which means this battery is going to become energized over the time. This is going to become more, this is going to continue to store energy, but this is going to be draining energy. For each coulomb of charge that this battery goes out and each coulomb of charge that flows to the external circuit, this is going to be losing 6 joule. This battery is going to be losing 6 joule of energy. 2 joule of that 6 joule is going to be used up over here, converting into light and heat, and 4 joule will be stored up in this battery for its purpose. That's the basic calculation for the voltage, or in joule per coulomb deviation. If you wonder, sir, why did you consider it to be X joule? I mean, couldn't you consider it to be exactly 6 joule and make it 0? The reason I do not prefer to do this anymore is because if I start with 6 joule and eventually at this point, apparently the energy of the 1 coulomb charge would become 0. Students always ask me this question: if the energy of the electrons becomes 0, why would they move? If they are moving, they're going to have some energy. So the answer is yes. The electrons can start with any value of energy, but they're going to spend a total of 6 joule of energy in the entire circuit. That's the basic idea of a 6 volt battery. That for every coulomb of energy that it makes flow to the external circuit. Every coulomb of energy is gonna bear out 6 joule of energy to the external circuit, and they are gonna eventually come back to the battery, losing 6 joule of energy. That's what it means. So, acha, I'll be taking some questions at this point. Sajid, bolo.
স্যার ওই যে ব্যাটারিটা আছে না, ব্যাটারির কথা যে বলতেছিলাম প্রথমে ওইখানে ব্যাটারি যে ইলেকট্রন ট্রান্সফার হচ্ছে, ওই যে রাইট সাইডের পজিটিভ টার্মিনাল থেকে নেগেটিভ টার্মিনাল যে ইলেকট্রনটা পাস করতেছে একটা সাইড, এটা কি ডোপিং প্রসেসে হয়?
No, it's not doping. It's basic electron transfer. These are all metal plates, metal wires.
আচ্ছা
There is no
আচ্ছা,
transistor or semiconductor materials over here. Bolo, আরেকটা কি?
একটা হচ্ছে ওই ধরে নেন আমি এখনো সুইচটা ক্লোজ করি নাই, আমি ধরে নেন সুইচটা এখন ওপেন রাখছি, আর ক্যাপাসিটরের মধ্যে কোনো চার্জ স্টোর করা নেই, না চার্জ বলতে হচ্ছে এনার্জি স্টোর করা নেই, মানে ওইটা জিরো এনার্জিতে আছে, নতুন একটা ক্যাপাসিটর লাগাইছি। তো এখানে কোশ্চেনটা হচ্ছে যে যদি আমি সুইচটা ক্লোজ করি তাহলে ওই ইনস্ট্যান্টে আমার ক্যাপাসিটরের যে প্লেটগুলো এ আর বি, এই দুটো প্লেটের মধ্যে কিভাবে ইলেকট্রন গুলো এসে জমা হবে, আবার কিভাবে ইলেকট্রন গুলো এসে মানে বি প্লেট থেকে এ প্লেটে যাবে, এটা বুঝি না, মানে এটা ভিজুয়ালাইজ করতে পারছি না।
আচ্ছা, এটা ভিজুয়ালাইজেশন দেখাবো, সমস্যা নাই, ডোন্ট ওয়ারি। আমি এই কোশ্চেনটা তোমার পরে আনসার করতেছি। লেট মি টেক আদার কোশ্চেনস, বাট আইল ডেফিনেটলি আনসার, show you a visual representation of this thing using hills and piles of electrons and depths of electrons. Don't worry, I'll do that. Fardin.
থ্যাংক ইউ স্যার।
Fardin.
স্যার, যে আপনি প্রথমে যে বলছিলেন যে আপনার ব্যাটারিটা সবসময় হচ্ছে কি ফিক্সড ভোল্টেজ দিতে থাকবে নো ম্যাটার হোয়াট, তো আমি ওই জিনিসটা বুঝি না, লাইক কেন ইট উইল অলওয়েজ গিভ আউট ফিক্সড অ্যামাউন্ট অফ ভোল্টেজ, মানে এনার্জি সেমটা প্রোভাইড করতে থাকবে, বাট ওই যে চার্জের ক্ষেত্রে কি জানি বলেছিলেন, আমি আই ডিডন্ট গেট দ্যাট।
Acha, what I say is that batteries are designed in such a way that you can continuously drain energy out of the battery, which is going to reduce the content of energy stored within the battery, but it's still going to be able to give you a fixed amount of voltage across these two plates. জিনিসটা এরকম, আচ্ছা আমি ফিজিক্যালি জিনিসটা বুঝাই, ফিজিক্যালি জিনিসটা বললে বুঝবা। How much voltage should a battery should be able to give out is dependent upon the rate of chemical reaction that happens between the cathode, anode, and the electrolytic solution or electrolytic material that exists between the cathode and anode of the battery. So it is largely dependent upon the electronegativity of these two metal plates, the concentration of the electrolytic solution, and also the contact surface area of the electrolytic solution with the plates. Three factors. The electronegativity of the metal plates, it means how willing the metal pieces are to give up electrons. So that's the measure. And second, how concentrated is your solution, which basically is a measure of your energy amount. And then third scenario is how much is the surface area of contact, or using exactly how much, thank you, using exactly how much surface area are we having the components reacting with each other, that is producing the voltage across the two batteries. The idea is this, that whenever there is enough concentration of the electrolytic solution, the entire contact surface area can do reaction with the battery. I mean, one of the way I can show you this, let's say this is one of the plates, let's say this is the one of the plate of the battery. Inside this plate, let's say we have a soaked sponge with acid, or polymer soaked with acid, that is existing over here. So this brown thing is the soaked polymer piece, and on the right side, let's say we have another metal plate. So let's say this green part is another metal plate. So these two plates are going to work as our electrodes. Let's say this is supposed to become negative and this is supposed to become positive by means of the reaction. So how much surface area do you provide the contact? This surface area is going to do the reaction, and because of the effect of the electrolytic solution, the chemical reaction that happens over here, your electrons are going to be continuously pulled out of the blue plate into the green plate. That's how you're going to have a voltage. Now, as long as this entire surface area keeps on working, you're going to have availability of reaction, and your reaction is going to keep on happening. I mean, you have to understand that, I mean, why the surface area is important, because even if you have, let's say, 1 billion eager particles to do the reaction, whereas let's say the surface only allows at 1 second, I mean, let's say in 1 second, the surface only allows 100 particles to do the reaction, because the surface have to provide electrons. So if the particles are big enough that at any point 100 particles can do the reaction, even if you have a lot of electron particles over here which can do the reaction, you can only have 100 particles doing the reaction per second. That is going to determine exactly how much voltage are you going to have across these two plates. Now, if you increase the surface area, you can make a bigger voltage. If you decrease the surface area, you can make a smaller voltage. And then again, how much energy capacity is the battery going to be is going to be dependent on how much acid or chemical energy did you introduce into the system. So if you make this entire thing much longer, let me do some painted magic. Let's say if we make this system like this, then the amount of acid that we could possibly store over here, the amount of chemical energy that we could introduce over here is going to become bigger. This would allow us to have the battery run at a much longer time because the entire chemical energy is going to be big. So the battery is designed so that it will always be giving a fixed amount of voltage across the two plates, because that is dependent upon the contact surface area and the reaction. Whenever we have used a battery that is non-rechargeable, and we have used a battery, or maybe rechargeable, doesn't matter. Whenever we have used a battery for a prolonged period of time, the total amount of, or the total number of available acid particles over here slowly becomes reduced. At one point, it happens so much, it comes to a certain point that you are going to have water particles or non-acidic particles in contact with certain parts of this metal surface other than acid particles. So you're not going to have 100 particles per second reaction. You're going to have, let's say, 80 particles per second reaction, something reduced value, because the concentration of the acid has become lowered. It has not drained entirely. It still has a significant amount of energy, but that amount of acid particles which is still left is not being able to make the same rate of reaction as earlier. That's when the battery's voltage is going to become down, and it will not be able to feed to our device, which is expecting that amount of voltage. That's when we discard a certain battery. Discarded batteries still have acid within them. Discarded batteries still have chemical energy within them, but it is still simply not good enough for us to use it to its fullest.
স্যার বুঝেছি, থ্যাংক ইউ স্যার। আরেকটা কোয়েশ্চেন ছিল।
বলো।
স্যার ওই যে আপনি যে বললেন স্যার 1 কুলম অফ চার্জ আপনার লাইক পুরো সার্কিটে যে ঘুরে আপনার হচ্ছে কি 6 কুলম অফ এনার্জি লুজ করে, ঠিক আছে? সো ওইটা কি স্যার আবার যখন স্টার্ট হয়, এটা কি আবার x জুল অফ এনার্জি দিয়ে আবার স্টার্ট হয় স্যার, মানে যখন ব্যাটারি থেকে আবার যায়? স্যার লাইক why does that happen? ওখানে যে কি
বলতেছি, that's exactly what the chemical reaction inside the batteries is responsible for. This 1 coulomb of energy, 1 coulomb of charge is gonna become energized from the chemical reaction of the battery, and they're gonna take out 6 joule of chemical energy from the inside material of the battery and come out of the positive on the battery by having that 6 joule of additional energy, and they can complete the cycle infinite number of times as long as the storage inside the battery can provide them 6 joule of energy.
Oh, acha, got it. Thank you, sir. Thank you very much.
Sure, no problem. Ashvia.
Sir, my question was, you said that in some devices the battery is low. I wanted to know the reason for it. I mean, I wrote that the charge cannot reboot to its voltage anymore. So I wanted to know the reason. You said that the battery is low in some devices.
Battery low becomes that the total amount of chemical energy that we started the battery at the starting of use, that amount of energy is gonna slowly become used up. So this example that I've shown over here, that for every 1 coulomb of charge that comes out of the positive end of the battery and eventually flows to the external circuit and comes back to the battery once again, this battery is gonna lose 6 joule of energy for each coulomb, because this has an output voltage of 6 volt for this battery setup, for this circuit setup. Which means if you keep this circuit on, this battery is gonna be continuously losing energy. For each coulomb of charge is going to be losing 6 joule of energy. Now let's say if you start this battery with, let's say, 6,000 joule of energy, 6,000, let's say at the beginning of when you buy a battery, fresh battery, let's say you had let's assume that we had a 6,000 joule of chemical energy stored within the chemical compound that was inside that battery. then what should happen? This thing would, this battery would be able, logically would be able to transfer 1 coulomb of charge across this entire external circuit 1000 times. Or it can transfer 1000 coulomb of charge, each losing 6 joule of energy to the external circuit. As a result, the total amount of chemical energy will be drained and this battery will become unusable.
Sir, I had one
Sir.
more question.
Bolo. Ashia, bolo.
Sir, that is capacitors store energy, not charge. What is the exact reason for it? Is it correct if I write that a potential energy is, I mean, the charge is same. I mean, the total number of electrons that is accepted and gained is always zero. I mean, the total charge is always zero. So therefore, capacitors store energy, not charge. Is it correct?
That is substantially correct, but there is more to it. I mean, the question that you're asking is for an explanation that how is it possible that the capacitors actually store energy? There is a much deeper understanding or explanation for how does a capacitor actually store energy, which I'm going to show you in a bit, which is called the dielectric process. It's a atomic level deformation. I'm going to cover that after a while. It is going to follow through in our lecture.
Okay, thank you.
Sure. Shubro.
স্যার আমি বলছিলাম যে 6000 জুলস অফ এনার্জি স্যার পুরোটা শেষ হলে তারপর কি ব্যাটারিটা ইউজলেস হবে নাকি তার আগেই একটা পয়েন্টে?
টিপিক্যালি তার আগেই শেষ হয়ে যায়।
স্যার লাইক প্রত্যেকটা মানে চার্জ পার্টিকেলকেই তো মানে 6 জুল অফ এনার্জি ক্যারি করবে অ্যারাউন্ড সার্কিট নাকি?
As long as you have the same rate of reaction with the electrolyte being in contact with the electrodes.
Yeah, but একটা পয়েন্টে তো স্যার এরকম আসবে না যখন লাইক ইট স্টিল হ্যাজ সাম এনার্জি লেফট বাট পুরাটা মানে 6 জুল করে প্রত্যেকটা চার্জ পার্টিকেলে দিতে পারতেছে না।
Yes.
So that is the point when the battery will stop working.
Battery will not essentially stop working. I mean, by designing a certain adaptive system, you can still drain energy out of the battery. But what is going to happen that at that kind of scenario, typically what happens for regular batteries that we human beings have developed over the duration of human civilization is that if you try to drain a battery beyond its, when its voltage is starting to fall down, the entire internal resistance of the battery starts to eat up the total available EMF. I mean, when the EMF starts to go down, then try to understand, you are using up the chemical energy available in the acid. So what is essentially what you are doing? You had ionized acid particles over the which was stored as chemical energy. Now, as you are slowly using them up, they are slowly becoming deionized. So you are having a loss of ion concentration, which means the conductivity of the battery is slowly becoming reduced. So, I mean, the answer to your question is that in a practical scenario, let's say if this battery was designed to feed a device which was rated for 6 volt output, I mean, it will never be able to give out all of its 6000 joule of chemical energy before it starts to lose its voltage. I mean, it might as well start to lose its voltage at, let's say, 4000 or 4500 or 5000. That can vary from design to design, but we necessarily cannot extract 100% of the chemical energy that is introduced into a battery through at any level. If we want to do that, we have to devise a adaptive system that can, as the battery's voltage is going to fall down, that system would also adapt to that reduction of voltage and would still be able to drain energy out of it, which is not impossible to design but not practical.
Like if with that device we can actually utilize the whole 6000 joule of energy in the battery.
Yes, it's not impossible to design, but it's not very practical.
Yeah, because sir মানে like আরেকটা যে ব্যাটারি আছে স্যার 4 ভোল্টের, right? So yeah, like ঠিক আছে, that's a different case.
স্যার
বলো।
স্যার একদম স্টার্টে আপনি যে বলেছিলেন না লেকচারে যে কিউ এর ব্যাপারে মানে ম্যাগনিটিউডটা,
Yes.
ওটা কি স্যার আপনার একটা মেটাল প্লেটের জন্য ক্যাপাসিটরের নাকি পুরো ক্যাপাসিটরটার জন্য ওটা কিউ চার্জটা?
This Q amount of charge would be always equal for both the plates. One will be negative, another will be positive. So for example, 10 coulomb plus minus 10 coulomb plus 10 coulomb minus 100 coulomb plus 100 coulomb minus 10 millicoulomb plus 10 millicoulomb. This is the amount will be equal for both of them. But whenever we say that a capacitor, let's say if I say that a capacitor is now charged with 10 coulomb charge, it means that the amount of charge stored in the capacitor is plus 10 coulomb is one plate and the minus 10 coulomb in the other plate.
Okay, sir. Thank you.
Sure. Acha, I'm going to address the question of Sajid first, because what I believe is that once I answer Sajid's questions, about 4 or 5 hands went down. So many of you might have had the same question, that you had difficulty visualizing how the electron flow actually happens. Let me show you what is happening. Let's say this is the battery. This battery, no. Let's say this is a battery. This battery pushes electron to the right side. So let's say over here we have a heap of electrons. On the left side we have a shallow region of electrons. So this is a full electron, filled up with electron. I mean, what is at the ground level, I'm not defining. And there is a shortage of electron. So this is basically what the battery plates are all about. This is the negative plate, this is the positive plate. This is trying to eat up electrons to come horizontal. This is trying to give up electrons by to become horizontal. What happens whenever these electrons, I mean, whenever if I have to try to explain this in physical particle term, I have to use the example of electrons. The way this thing works is that these electrons come out of over here because of the push of this negative side and the attraction of the positive side. And as they slowly flow through the external circuit, so they're going to lose their energy in some places, and they're going to give up some energy in some places. And eventually they're going to come up over here, and they are going to fill up over here. The chemical energy of the battery, or the chemical reaction that happens in the battery, is sort of like a pump. Let's say there exists a pump over here. This pump is continuously pumping up the electrons from this place, and it is making this heap. So this chemical energy, or the chemical reaction, or that interaction, that chemical reaction is responsible to maintain this level at a certain depth and maintain this heap at a certain height. That's basically a sort of a visual representation for the voltage. I mean, the deeper this level is, and the taller this heap is the higher the voltage the battery can give. And the longer this pump can work, longer this battery can give you energy. So how long will this pump work? That is dependent on how much energy chemical energy did you start to work for this pump. So if you started with a bigger amount, this pumping process is going to run faster or longer, and vice versa. So did it answer your question? The chemical reaction of the battery works like a pump, which is continuously pumping electron from the positive end of the battery, let's say this, which is this side, to the negative side of the battery. So it is producing a shallow region of electrons. So it is producing a shortage or paucity or calamity of electrons over here, and making an abundance of electron on the other side. That's the purpose of this pump. This pump is continuously pumping electrons from this level to this level, and it is continuously maintaining the heap at this level and maintaining this depth at this level. The difference of these two levels is basically what is the express voltage of the battery is. If this reaction can work really, really strongly, this heap might as well be even taller, and this depth might as well be even deeper. For example, we can have 9-volt batteries, which we use for our multimeters, and we can also have 1.5-volt batteries. So the 9-volt battery, the reaction rate is really, really large, whereas the 1.5-volt battery, the reaction rate is not that large. So in other words, I can say that the electron pump for the 9-volt battery is extremely powerful, whereas the electron pump for the 1.5-volt battery is not that powerful. Then again, there is another example that we can have AAA batteries, which we use in the remote controls. Then we can have double batteries, which we use in some remote controls, but we can also use them in what double battery remote control cars or stuff like those. And then we can have single A batteries, which are usually used in the torchlight, like those big cylinder batteries. Have you guys ever seen these things, like the big batteries?
আসলে দেখছি
লাইক
আগে
like
ট্রেন
a
ইউজ করতাম
like হ্যাঁ মানে লম্বা টর্চ লাইট গুলোতে ইউজ করা হতো so what you need to understand that all of these batteries they are rated at as 1.5 volt all of these batteries have the same voltage rating the only difference is they simply contain different amount of energy this battery contains a much smaller amount of chemical energy this one is contains a much bigger amount this one contains even a bigger amount which means you're going to be preferably design an electric device where this set of battery is to be used where the requirement of energy is essentially low. For example, a remote control. A remote control essentially produces a small bit of infrared signal exclusively when you press some button. If you don't press any button, the battery is not going to be drained. So it's a need to spend sort of thing. You can use this battery for decorative purposes, for example, remote control cars and toys and stuff like those. Whereas we use this thing in very powerful torchlights where this is going to be required for those purposes. So these three different shapes basically represent that for each of these battery, the total amount of reaction area, which is going to define the voltage, is essentially same. They are designed in that way. But the amount of material, chemical material, which is going to work as the source of our energy, that is going to be different in different of this shape of the batteries. বুঝতে পারছি?
জি স্যার
আচ্ছা অর্ণব একটা কোশ্চেন করছে আমাদেরকে চ্যাটে অবশ্যই কোশ্চেন একটু দেখি what is the benefit of reverse connection rather than straight up connection? Will there be loss of efficiency power in the reverse connection? If so, why are we doing that? Well, the loss of power is essentially coming from the idea of how much heat loss is happening for using the formula P equals to I square R. Now, this R should not be written as R. I can write this at, let's say, R1 plus R2 plus R3. আমাদের অনেকগুলো R থাকতে পারে, plus battery internal resistance of কিছু R থাকতে পারে. So let's say I can write the R in this format. So the basic idea that you can achieve a bigger efficiency if this is less. The lost heat is less and the utilized form or expected form is more. So essentially speaking, if you can reduce your current value, your loss should become less compared to your resistance because there is a square over here, which means if you can operate a certain voltage, think about it, V equals to IR, right? V equals to IR. If you want to reduce the current in a circuit, you either have to increase the voltage for a resistance or you have to reduce the voltage. Now, changing R might not be a pragmatic option because if you're operating a physical circuit, your battery has a fixed shape, which means it comes with a certain value of internal resistance. And then your electronic device, all the devices that you're going to run with the battery, let's say some LED lights, some musical devices, some motor to run a toy, very simple example. Those things are going to eat up give the resistance. So the resistance is usually not changeable once you already have a definitive product. So essential idea is that R is not actually changeable thing once you already have the device. So all that you are left with to reduce the voltage. So the smaller voltage you are going to operate the device at, the less heat you are going to generate because your current will become even smaller. Smaller current will also mean that the rate of heat energy transfer will also be smaller because effective power is also given by P equals to VI. If your current is pretty small, your output power should be also small. Which brings us to the idea that if you operate devices at a very small voltage, you should have that efficiency of the device to be even bigger compared to high voltage devices. This is exactly why hand watches যে ব্যাটারিগুলি থাকে, they are usually rated at 0.7 volt because you do not want to replace these batteries too often. Then again, because of the space constriction, you cannot design the hand watch batteries to be really large. That's not pragmatic. So that's where efficiency comes in. The benefit of having a battery connected in reverse direction is one, that is whenever you connect a certain battery in reverse orientation with a bigger source of the battery, bigger voltage source, you can charge up that battery by reversing the chemical reaction within the battery. But the battery has to have that reversible chemical reaction compounds within itself. I mean, for example, you cannot use regular sunlight dry cell to be rechargeable because they are made from ammonium chloride, which actually goes out into the air as ammonium gas coming out of the battery in a very small amount. We never smell that. So that's not reversible. But for rechargeable battery, reversible batteries, for example, lithium ion batteries, or let's say alkaline batteries, there are certain designs. Those things are rechargeable batteries, which means they have reversible reaction. So for whenever you are draining them, they're gonna give one type of reaction. whenever you connect them for the rechargeable process, you convert them into, you do the exact opposite reaction. So by doing the reaction back and forth, you can charge up the battery. So typical benefit to have a battery connected in reverse polarity with a bigger source is to having it charged. Basic idea of charging all of the devices that we charge in our regular life. Cell phone. Cell phone is the most common example. I cannot think of other example, etc.
Venn diagram generator.
Venn diagram generator. Venn diagram generator. Venn diagram generator. Venn diagram generator, as far as I understand the mechanism of Venn diagram generator, it doesn't work with the reverse connection. It works with as a continuous push of electrons from one place to another place by physical contact and rubbing. So that way the sphere,
static energy.
so that the metal sphere or metal dome slowly gets charged in a fixed type of charge. Usually Van de Graaff generators do not have battery. As far as I understand, Van de Graaff generators do not work with batteries. They work with belts and pulley systems which continuously make the transfer of charges. Shubhu, if you don't have any question, please lower your hand. I appreciate that. So I'm going to get back to the discussion. So where I left off. So this is the battery that I was talking about. So what I want you to understand that whenever this capacitor is slowly becoming charged over the time, this will inherently try to produce its own current in the reverse direction, but it cannot produce this current because by default this is the bigger voltage source. So what is going to actually happen? The thing that is going to happen over the time, as the battery after closing the switch, as current is slowly charging up this capacitor, the effective EMF of this circuit, consider this term, the effective EMF, or you can write total EMF of this circuit, is going to become reduced, because at t equals to 0, the capacitor did not produce any reverse EMF because it was altogether 0. So the total EMF was 12 minus 0 volt. That was at t equals to 0 second. Let's say after t equals to 1 second, let's say the capacitor now has a voltage of, let's say, 1 volt. It means the effective voltage EMF of this circuit is going to be 11 volt. If after 2 seconds, the capacitor has, let's say, 1.8 volt, then the effective EMF is going to be 12 minus 1.8. That is how much? 10.2 volt. So it's going to be working like that. If you wonder, Subro, please raise your hand before you ask your question. I really appreciate this. If you wonder that why did I not give a linear decrease over here, there is a reason for this, which I'm going to cover in a bit. But for the time, you just take my word that because the capacitor is continuously producing a reverse EMF, the total EMF of the circuit is becoming reduced because battery is trying to produce its current in this direction, and this capacitor is going to try to produce its current in the reverse direction. Very much similar like these two batteries are connected in opposite polarity. Have a look. Positive and positive are connected by a single wire, where the negative side is connected through a resistor through the same side. That's basically what we mean by reverse polarity. Have a look. It's a negative connected. It's positive So that's why the effective voltage of the circuit becomes less. Now, one more thing we need to consider. The basic formula for current flow is given by Ohm's law, V equals to IR. In this entire circuit, the total resistance of the circuit is constant. For example, let's say the resistance of the circuit is only R. That is the resistance of this fixed resistor. So if the V is slowly becoming less, logic tells us that I should also become less. Now, if I become less, it means this capacitor will not be charged as fast as it was charging at the beginning. As time goes by, the rate of charge flow is reducing. Try to understand. If I give you some number, let's say at the beginning, let's say the current flow was, let's say, 1 ampere. After a while, the current flow becomes, after a while means, let's say at t equals to 0, the current was, let's say at t equals to 0, the current was 1 ampere. Then let's say after t equals to 1 second, the current reduces to, let's say, half ampere. So what is happening? Within this time, the current got decreased. So essentially, within the next 1 second, after t equals to 2 seconds, the amount of charge that the capacitor could gain for this amount of current flow, which is an average of, let's say, 0.75 for this duration. Just I'm doing mathematical average to make sense with it. It's not going to be mathematical average, but just to make sense with you. If I take that for this duration, the current was average current was 0.75 ampere. The capacitor did gain some voltage, but Once the capacitor does gain some voltage, it's going to work as a reverse voltage and reduce the available current that happens within itself. As a result, after 2 seconds, the current will not be reduced to 0. Current will be reduced further from 0.5. Let's say that then the current becomes 0.3 ampere. So what is going to happen? For this duration, the current flow is going to be even smaller. And that cycle is going to continue. That less available voltage is going to cause less current. Less current is going to do less charging. Less charging is going to do less reduction of available voltage. And this thing is going to feed onto its own self. As a result, the actual curves of this capacitor charging, they have curved shapes. So those shapes are, I believe we have them in the lecture. So it comes up over here. What? These are the graphs for charging scenario. Have a look. Capacitance জিনিসটা কি সেটা ডেফিনিশন এখন আমি বলি নাই, ক্যাপাসিট্যান্সের ডেফিনিশন আমি একটু পরে বলবো, but I really want you to understand these graphs. What is happening over here? Initially, I mean, one of the slightly wrong thing that happened for this line. One of the slightly wrong thing that happened over here is that this line, this curve should not touch the x-axis. I mean, this is supposed to become asymptote and it should not touch the x-axis, but for practical purposes, we can consider that at certain point, we are going to consider that difference to be 0 or negligible, and we're going to merge the graph. For practical purposes, we can do that, but mathematically, it should never become touching the x-axis. It should never become touching the x-axis. So what is happening? Initially, the current is very high. Why the current is very high? I'm coming to this graph a little bit later. Try to understand this one. When we close the switch, the voltage of the capacitor, the voltage, this V represents the voltage of the capacitor. And Vs represents the phase voltage of the battery. Let's say that was 12 volt for our example. So whenever we close the switch, the capacitor voltage was 0. As time goes further, the voltage of the capacitor increases. But it does not increase by the exact equal amount for the next amount of time. Why? Because as the voltage of the capacitor gets increased, which we showed over in this figure, as the voltage of the capacitor, which showed in this figure, as the voltage of the capacitor become increased, the effective EMF of the circuit become decreased, which means equal amount of current does not flow through the circuit anymore. Which brings us to the idea that the current flow is going to slowly become reduced. So you're going to have the highest current through the circuit at the beginning because you have a fixed resistance and you only have the entire EMF available from your source. But as time goes by, your reverse EMF slowly becomes bigger and bigger and bigger, which is the voltage across the, not reverse EMF, reverse voltage, which is the voltage across the capacitor. As a result, your total available EMF or effective EMF becomes smaller and smaller and smaller. So as current goes lower, the charging rate becomes smaller. That's why the capacitor does not charge as fast as earlier. That's why it is losing gradient, and eventually it comes to horizontal to a value of the 12 volt value. 12 volt is the source voltage, which means that if we connect a capacitor to a certain source, maximum voltage that the capacitor can have is going to be equal to the source voltage. Because what is going to happen when the capacitor actually reaches 12 volt? Consider this circuit once again. Let's say at some point, this voltmeter is giving us a reading of 12 volt. This means now the total amount of effort this battery is trying to make the clockwise current is exactly equal to the amount of effort this capacitor is trying to produce an anti-clockwise current. These two efforts or these two opposite EMFs are going to cancel each other out, and there would not be any resultant current in the circuit. Theoretically, this process is going to take forever because this is a negative exponential curve. But for practical purposes, we are never going to we don't ever measure a current up to infinite number of decimal places. So আমাদের ডিভাইসে যত decimal place দেখা যাচ্ছে ওখানে 0 আসা পর্যন্ত আমরা 0 ধরতে পারি. That might actually have a finite amount of time. For example, let's say if we are able to measure the current value up to a precision level of a certain gap. Let's say this is the place where this is the time frame where our ammeter is showing us 0 current. So we can practically merge this graph with the x-axis, but for your actual drawing, you should never do this. This line should be asymptote to the x-axis. As for the Qmax জিনিসটা কোথা থেকে আসে? Qmax এখানে একটা ইকুয়েশন দেখা আছে, দেখো Qmax equals to C into Vs. এটা কোথা থেকে আসছে সেটা আমি বলতেছি। This is what the definition of the capacitor is coming up, which is going to be shown in the next page, but I'm just covering this up over here. The definition of capacitance. Capacitance এর basic definiting phrase হচ্ছে this is a definitive phrase. এটা আগে পরে তুমি আরো অনেক কিছু লাগাইতে পারো এটাকে বড় করার জন্য, আরো বেটার এক্সপ্রেসিভ করার জন্য। So what this means is the charge stored per unit voltage across the plates. This means, let me give a physical example so that it is better visual, you can visualize it easier. Let's say we have a neutral capacitor which is not charged over here, and then let's say we have a voltage source over here, let's say plus and minus, an artificial voltage source. We can also have a battery just to limit the current so that the battery does not become, we have a switch over here, and let's say we are going to connect a voltmeter over here, and we are going to have an ammeter, or we are going to have a coulomb meter. Coulomb meter symbol হচ্ছে C. We're going to have a coulomb meter on this circuit connected. So it's going to measure the exact number of coulomb that is passing through. So if we have a scenario like this, let's say we're going to close this switch and we're going to keep observing the voltmeter reading and the coulomb meter reading. This voltmeter reading is going to start from 0 volt and it's going to slowly increase, and eventually it is going to reach, at one point it's going to reach 1 volt. It can go even further depending upon the value of the source. Let's say this source have to be bigger than 1 volt if I want to make this 1 volt, but there's going to be a certain number of time. The amount of charge that will be registered over here to make the voltage difference across the two plates of the capacitor to be 1 volt. That amount of charge is what we define as capacitance. Or in other words, if I write in equation, capacitance C is given by Q by V. Capacitance form unit হচ্ছে farad, which is given as coulomb per volt. So in other words, I can define 1 farad is basically 1 coulomb per volt, which means if a capacitor is such that to maintain 1 volt potential difference across the two plates of the capacitor, we need to provide 1 coulomb charge into the capacitor. The capacitance of that capacitor is 1 farad. I'll say it again. To maintain 1 voltage potential difference across the two plates of a capacitor, if we have to provide 1 coulomb charge into the capacitor, the capacitance of that capacitor is 1 farad. So এটা হচ্ছে আমাদের ক্যাপাসিট্যান্সের ফর্মুলা। সো এখান থেকে যদি আমরা কিউ কে, এটা হচ্ছে ভি, এটা হচ্ছে ক্যাপিটাল ভি ভোল্টেজ এটা। সো এখান থেকে যদি আমরা কিউ কে সাবস্টিটিউট করি, what we're going to get? We're going to get Q equals to CV. So this is the formula for charge. So maximum charge stored capacity কত হবে? একটা ক্যাপাসিটরের ডিফল্ট ক্যাপাসিট্যান্স হচ্ছে তার স্ট্রাকচারের উপর ডিপেন্ডেন্ট, which is a fixed number. It is not infinite. It is not indefinite. A capacitor has a limited number or measured number or certain limited value of capacitance. It depends upon its structure, material, and the dielectric material in between the two plates. সেটাকে একটু পরে বলতেছি। So this is the charge stored in the capacitor. So for a fixed capacitor, or the examples that we're gonna go for, let's say if we consider for an ideal capacitor, this C is a constant number. So if you increase the value of V, you're gonna have increase of Q, which means if you have an ideal capacitor means an ideal capacitor is capable of store indefinite amount of charge under the effect of indefinite amount of voltage. It's not gonna fail, which does not exist in practical life, but that's the whole idea. That's the whole point of using the word ideal. Like you have known that ideal gas, it doesn't exist. So an ideal capacitor is something that can be assumed to be able to withstand indefinite amount of charge across in its plates after under the effect of indefinite amount of or infinite amount of voltage. Practical cases এটা হয় না। Practical cases এটা হয় যে if we start to charge up a certain capacitor to a very higher voltage, at a certain point the voltage difference across the two plates becomes so high. Let me show you in this figure. At a certain point, the voltage across these two plates becomes so high that electrons starts to jump from the negative plate to the positive plate, which is basically what we call short circuit, or they're gonna produce spark. If there is a physical material in between, they are gonna melt that physical material, and they're gonna pass from one plane to the other end. Basically, it's a small scale lightning can happen. And whenever this is going to happen, if you apply the voltage to such a high value, then the capacitor is going to become discharged within itself. The whole idea is that the capacitor do not have enough capability to sustain that amount of voltage. So that might as well be its limiting value of the voltage under which the capacitor can work. There's a maximum value of the capacitor at up to which that capacitor can be useful. If you apply a voltage bigger than that limit, that capacitor is going to fail. Failing means it's going to become short-circuited across its plates, and it's not going to work as a capacitor anymore. You cannot have the separation of charges for that amount of high voltage. This depends on the design, and this also can come in very miniature version, like microscopic or super microscopic version. This can be very large as well, depending upon the application scenario and other processes. So the point that I was trying to make, I was trying to actually explain this value, that what do we mean by Qmax. So for our source, for the example that I was showing on the earlier page, our source voltage Vs was 12 volt. So this is the maximum voltage the capacitor can have. So the maximum charge that the capacitor can has is going to be given by C into source voltage, because source voltage is the possible maximum voltage a capacitor can be provided for a certain given circuit. So if you do the product of these two factors, you're going to get the maximum Q, which is giving up this horizontal level. And that's what is written over here, that Q max equals to C into Vs. It's a bit light. I think this was written in pencil. That's why it shows light, but this is very important information. So to summarize, and after this, I'm going to take some more questions, is that whenever the capacitor is charged from neutral, its stored charge amount is going to slowly increase, and it's going to increase in a decreasing gradient pattern, and it can have a maximum charge where Q max equals to C into capacitance into source voltage. The maximum voltage that the capacitor can get is the source voltage. And for the current graph, the capacitor is going to start to get charged at a really high current. As time goes on, because of the opposite voltage that the capacitor introduces into the circuit, the current, if the current in the circuit is going to reduce, and this is going to reduce in a negative exponential shape, or the current value or the current curve should become asymptotic with the time axis. And for practical purposes, at some point we can consider that gap to be negligible, and we can consider that the current has become zero within the limitation of our measurement equipment. So that's about certain parts that I want to discuss. I did not yet answer Ashfia's question because that's gonna be the very next point that I'm gonna discuss after I take these questions. Yes, Shubhro, bolo. You were about to ask a question.
স্যার আপনি কি বললেন যে ইএমএফ টার রেটটা আস্তে আস্তে কমতেছে বিকজ রিভার্স ইএমএফ এর কারণে ফ্রম দ্য ক্যাপাসিটর?
EMF rate now. EMF value. Rate means the change of something with respect to time.
স্যার বাট এখানে গ্রেডিয়েন্টটা দেখাচ্ছে না স্যার, ভিএস ভার্সেস টি গ্রাফটাতে।
Yes, the EMF is the effective EMF of the circuit is decreasing because of the increase of the voltage across the capacitor. These graphs are for the capacitor property, not for the whole circuit.
আচ্ছা 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 আচ্ছা। হ্যাঁ, ইফেক্টিভটা স্যার কমছে, তাহলে ইএমএফ এর যে মানে রিভার্স ইএমএফ যেটা পাচ্ছে।
Exactly.
রাইট।
হ্যাঁ। অরুণিমা।
স্যার আমি একটা জিনিস বুঝি না, গ্রাফগুলো কার্ভড কেন, লাইক আই ভার্সেস টি আর ভিএস ভার্সেস টি, এটা বুঝতে পারছি না।
আচ্ছা, এটা একটা ম্যাথমেটিক্যাল এক্সপ্রেশন আছে যেটা ইন্টিগ্রেশন করে পাওয়া যায়, বাট আমি তোমাকে বেসিকলি একটা জিনিস বলি, মানে নরমাল একটা জিনিস বলি। সেটা নরমাল জিনিসটা হচ্ছে এরকম যে ফিজিক্যাল একটা এক্সাম্পল কিরকম হতে হবে, হোল্ড আপ। তুমি প্রচন্ড ক্ষুধার্ত অবস্থায় সুলতান ডানে কাচ্চি খেতে গেছো, and food has been served. What's going to happen in the first 1 minute of your eating? You're going to be galloping food, or I'm going to be galloping food. Let's say I use myself. I'm going to be eating food without tasting it much. As my stomach is going to slowly become more and more filled, I'm going to become more and more relaxed, and my intake rate of food is going to become reduced.
Yes.
That's essentially what is happening over here. When the capacitor is at zero voltage, the effective EMF of the circuit is very high because there is no reverse voltage. That gives you a much higher current. Let's say food is going to my stomach. That is the current. Okay. As the reverse voltage slowly becomes to get bigger, or let's say my stomach is slowly become fuller, the requirement of the food flow will reduce. Or in other terms, the current flow is going to become reduced because the effective EMF of the circuit is become reduced. So the rate of charge flow that was available at the initial stage of the switch closing, that intensity of flow would not exist further down the time, because you are gonna be slowly producing an opposite voltage across your capacitor, which is gonna reduce the driving force of the current. V equals to IR. That V essentially means what is the total EMF of your circuit. So your R is a constant value for the circuit that we have shown for in over where for this case. Let's say for this case. So as we are as the reverse EMF is slowly becoming bigger and bigger and bigger. I mean, in other words, I can just write this equation if it makes better understanding, that the current in the circuit can be given like this: source voltage minus voltage of the capacitor divided by the resistance. এই কোশ্চেনটা কি বুঝতেছো?
Yes, sir.
এটা বুঝা যাচ্ছে?
জি স্যার।
তো ওভার দ্য টাইম তো এটা আস্তে আস্তে বাড়বে না?
হ্যাঁ।
তাহলে অবভিয়াসলি এটা কমে যেতে হবে না?
হ্যাঁ হ্যাঁ হ্যাঁ।
আচ্ছা, এটা হচ্ছে কমে যাওয়ার কারণ। এখন কথা হচ্ছে ওইভাবে কেন কমবে? কারণ হচ্ছে this VC is actually feeding up by the process of the current. When let's try to understand how much voltage would be available will be gained by the capacitor is highly dependent on how much current is flowing through, because Q equals to IT. Q equals to IT. If the current value is large, then within the same amount of time you can supply bigger amount of charge. If current is small, then the supplied amount of charge will also become smaller, right? So try to understand. Let's say Q equals to IT. So if I take T as a constant, because I'm trying to compare for different time instances, because the graph had a shape like this. So let's say I'm going to try to consider for equal time instances what is happening for equal time instances. So if I is becoming less, the Q should also become less, right?
Yes.
And Q equals to CV, or V equals to Q by C. If the stored Q over equal segment of time is becoming small, then the voltage gained by the capacitor will also become less. Let's say in the first 1 second duration, it gains 1 volt. Then obviously in the next 1 second is not going to gain 1 volt, because that 1 volt is going to start to produce opposing effect on the battery's current, and it's not going to have the same amount of current as the first second. The available amount of current in the circuit is going to be less compared to the first second.
Yes, sir.
So you are going to have a gradual decreasing effect, which means the further your capacitor becomes charged, the more opposition it provides, which reduces the current, which in turn reduces the amount of voltage gain, and that reduces the amount of reduction of current value as well. So you're going to have reduction of current, but you're going to have that current reduction more leniently further down the line.
The last line বুঝলাম না।
আমি আবার বলতেছি, তুমি cause and effect গুলো বুঝো. If you have if the point where it stop making sense to you, stop me at that point. The longer you, I mean, initially there will be high current increasing the voltage of the capacitor at a really high rate. The more the capacitor become charged / the more the voltage across the capacitor gets increased, the current will be opposed, because the effective EMF is going to become less. So less current is going to flow in the later seconds or later time compared to the earlier time, because the effective EMF of the circuit is gradually decreasing. Since current is flowing less, so the voltage gain rate of the capacitor is also becoming less, because now within the same amount of time, less charge is transferred to the capacitor. So if it was gaining, let's say 1 volt in 1 second for the first second, in the next second, it's not going to gain 1 volt. It's going to gain less than 1 volt. In the next second, it's going to gain even less than 1 volt because the rate of charge flow has reduced. Or in other terms, I can say that, বুঝে গেছে?
জি স্যার বুঝতে পারছি।
Beautiful. It's sort of like a vicious cycle. That one thing is reducing the other one, that is also reducing the other one, that is also reducing the other one. So it all comes to in a negative exponential curve and it all becomes an asymptote.
Sir,
এক মিনিট আসবে হাত উঠাও ইয়া সাজিদ হাত উঠেছিল সাজিদ বলো
স্যার এবার কোয়েশ্চেন হচ্ছে যে ওই ক্যাপাসিটরে নর্মালি যদি ইলেকট্রনগুলো থাকে ওগুলো কি নর্মালি মানে ম্যাক্সিমাম ভোল্টেজ ধরে নেন ওরা ওর কাছে আসে ও তো ম্যাক্সিমাম ভোল্টেজে যাওয়ার পরেই ওই স্পার্ক গুলো হবে কিন্তু ধরে নেন ম্যাক্সিমাম ভোল্টেজে নাই অথবা মাত্র চার্জ হওয়া শুরু হয়ে একটু মানে ফার্দার ডাউন দ্য লাইন গেছে তো ওইখানে তখন ও যে এনার্জিটাকে দিতেছে একটা প্লেট থেকে আরেকটা প্লেট এই তখন আপনার কিভাবে ইলেকট্রনগুলো যায় একটা
এটা 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 আমি তোমাকে বুঝাবো মানে ইউ আর বেসিক্যালি আস্কিং হাউ ডাজ দ্য ক্যাপাসিটর স্টোর দ্য চার্জ তাই তো হ্যাঁ এটা আমি একটু পরে আসতেছি আসবে বলো আমি এই এই তোমাদের সব কোশ্চেনগুলো শেষ করে আমি এটা আলাদা করা শুরু করব আসবে এইভাবে কোশ্চেন
sir, is this related to the Lenz's law? You just said the more the voltage increases, the more the charge will oppose the change. So just like Lenz's law, one quantity will oppose the change to another quantity. So does it have any relation to Lenz's law? This you said to answer Aruниma's question that the more the voltage increases, the charge will oppose the change.
It is not physics wise or physical reason wise it is not related to Lenz's law, but the effect that you mentioned, Lenz's law, that has a similar type of change behavior like this one, but they are not related because Lenz's law deals with electromagnetic scenarios. Here we are dealing with exclusively electric scenarios, but their change behavior are quite similar. So the similarity that you have pulled is very related, but they are not reason wise related, but their behavior was related. Could I make sense?
Okay.
বুঝা গেছে কি মানে দুটো জিনিস একই রকম বাট একই না okay the other question that readers have been asking me which I have been postponing for a pretty long time is that how does a capacitor store charge? This is explained. Acha, before I move on, I want you kids to read one paragraph. I'm sorry. Everyone, please read this paragraph and try to make sense out of it. 6 line, 1 minute. বুঝা গেছে
স্যার এখানে যদি কোনো রেজিস্টার অ্যাটাচ থাকতো তাহলে তো আবার কম আসতো ক্যাপাসিটরের পিডি রাইট
রেজিস্টার অ্যাটাচ থাকলে আমাদের স্টার্টিং কারেন্টের ভ্যালুটা কম হতো
হ্যাঁ
ইনিশিয়াল
স্টার্টিং পিডিও না মানে ক্যাপাসিটর পিডি কম হবে না রাইট
ক্যাপাসিটরের পিডি গেইনটা আরো স্লোলি হতো
but they would reach the source voltage
ultimately given enough time, yes.
but sir রেজিস্টার না একটা ভোল্টেজ খেয়ে ফেলতেছে
That's the beauty of capacitor, that the capacitor slowly stores charge and it can reach up to the voltage of the source. That's when the entire current flow in the circuit becomes zero, practically zero, and that's when the entire all the PD is consumed by the capacitor only. All the other components in the circuit essentially consumes 0 PD at that point, because PD is given by V equals to IR. When I becomes 0, irrespective of R, V is also 0. Or in
So
other,
why does such thing happen actually?
because the capacitor produces a barrier path between the flow of continuous flow of charges. So it produces it accumulates the charges in two opposite plates, and it slowly increases its voltage gradually.
Sir, voltage actually accumulate করে কিভাবে in the capacitor? Like does it depend on the surface area you are saying?
It becomes on a certain atomic level scenario, যেটা আমি একটু পরে আলাপ করতে যাচ্ছি। অর্ণব,
স্যার এখানে টাইম ডিলে কনস্ট্যান্ট কোনো কাজ করে না?
বুঝি নাই।
টাইম ডিলে কনস্ট্যান্ট
Time delay constant, মানে what do you mean by that? I'm sorry.
ক্যাপাসিটরে টাইম দিলে হয় না স্যার?
ক্যাপাসিটর সার্কিটে ইউজ করে আমরা টাইম ডিলে ইন্ট্রোডিউস করতে পারি। দ্যাটস ওয়ান অফ দ্য ইউজেস অফ টাইম ডিলে, one of the uses of a capacitor component. That's applicable for a special design of circuit where capacitors can introduce time delay for a secondary circuit to become activated. That's possible. That's one of the uses of capacitor. But I'm not sure exactly how are you relating that to this question? Questionটা আবার বলো।
ইফেক্টিভ ইএমএফ অফ দ্য সার্কিটে ওই ফর্মুলায় টাইম ডিলের কোনো ফ্যাক্টর কাজ করতেছে
না, করতেছে না, এখনো বন্ধ না।
ওকে
আচ্ছা, ওকে, আই হোপ ইয়া বলবান এই জিনিসটা একটু পড়ো সবাই। Does it make sense? All right, let me elaborate this a bit, and then if you have any questions, I'll entertain your questions. What essentially happens that whenever let's say we have a insulator material between the two plates of the capacitor. Let's just assume any insulator material, glass, plastic, rubber, wood, whatever you think. Preferably not gas for your visualization. That might give you some trouble because you will have to assume that the particles are moving around. Just consider it's a solid material, which is an insulator material for the sake of simplicity. Whenever we apply the voltage, this voltage is going to affect the electron and the nucleus of that atoms individually. The entire electron cloud is going to be attracted towards the positive plate, and the nucleus is going to be attracted towards the negative plate. So they are going to become slightly like a bit elliptical, or you can say more like an egg shape, where the pointy head of the egg is the electron cloud getting shifted towards the positive plate, and the nucleus is going to be shifted towards the negative plate. This statement, what we have over here, this statement that as a result, the centers of positive charge and negative charge do not coincide. Let me explain this line. For a neutral atom that is not under the effect of any electric field, the nucleus is located at the geometric center, and the electrons are uniformly distributed around them in a circular pattern. So if you draw the electric field of the electrons, if you draw the electric field of the protons, you're gonna have both of those fields to have the same starting point, which is the center of this atom. That's what we mean that the center of the positive charge and center of the negative charges. Center of the negative charges means that if you consider all of the electrons that is around the nucleus as a, if you assume that them to be a single particle, so exactly where that particle should belong. So that nucleus and that hypothetical center of the concentrated form of all the electrons, they would perfectly coincide at a single point for a neutral atom, this is for an uncharged atom, neutral, not for an uncharged atom. Whenever we apply this electric field by charging the two opposite plates of the capacitor, then the electrons are going to be more shifted towards the positive plate and the nucleus is going to be more shifted towards the negative plate. We are talking about an atomic level deformation. This kids start to understand. This would not be visible in naked eye. If you introduce a plastic piece, or even if you introduce a gelatin piece in between the two plates, you would not see that material is becoming elongated. You will not see that. Each individual atom remains in their original position. The intermolecular spacing also remains the same. Only each atom are gonna become slightly deformed. And deformation means you have stored some sort of potential energy. And that potential energy is the mechanism by which a capacitor stores energy. So what happens whenever we charge up the capacitor, all the atoms in between the two plates, they slowly become deformed. And each slight bit of atom deformation stores a small amount of energy in that atom. Because we are talking about atoms, so even in a small amount of atom, there are billions of atoms. So they all together can store up significant amount of energy as a resultant sum, as a total sum. So that's what happens in the process of charging. Whenever discharge means if you allow a capacitor to be drained through an external circuit. Let's say if you want to light up a light bulb using the energy stored from in a capacitor, or you want to blink a certain LED bulb for a flash of a light, or neon lamp for a flash of a light. Capacitors are very commonly used in all sorts of neon lamps, because whenever your neon lamp is going to glow, it's going to suddenly require a high amount of energy, which a capacitor can readily provide. A battery cannot provide this kind of variable amount of output energy, because battery works with a fixed surface area of reaction rate. But capacitors can store up that energy over a duration of time and then suddenly give up all the energy as the circuit requires. So when the capacitor is discharged, all of these atoms can come back to their original shape. Atoms will come back to the original shape, and the energy that was earlier stored is going to be given up. This type of energy is what we call electrostatic potential energy. We do not call it elastic potential energy, because the object does not get physically deformed. Atoms within the object becomes individually deformed by the effect of an electric field. So the name of this energy is electrostatic potential energy. I'll take questions. Sajid, bolo.
স্যার এখানে যে আটমটা আছে এটা কি ওই ইয়েটার ভিতরে আছে, মানে ক্যাপাসিটর যেটা প্লেটের মাঝখানে আছে?
Yes. But এখানে just দেখানো মানে for ideal case, this figure should have two vertical lines over here to represent discharge plates. এই দুটো লাইন আঁকা হয় নাই।
আচ্ছা। আর স্যার আরেকটা কোশ্চেন হচ্ছে, এটা তো আপনি দেখাচ্ছেন যে একটা মিডিয়াম পার্টিকেল থাকলে কি হইতেছে, যদি ভ্যাকিউম হয় তাহলে তখন কি হবে?
If the space in between is vacuum, then we are gonna have distribution of the electrons on these two plates. So what's gonna happen for the distribution? If you consider this metal plate is actually a metal plate, so let me take out this picture and maybe show you by a bit zoomed in view. Why? So if we have an empty space, let's say if I draw an empty space, let's say this is a capacitor which has no medium in between. And if we are trying to charge this up, what happens? The electron distribution within this plate, that becomes the source of energy. For example, if this was uncharged, the center of positive charge for this entire bar and the center of negative charges for all of this bar would be at the same location. But whenever you will connect this to a, let's say, negative charge, and then you have connected this to a positive charge, there are going to be electric field that will exist between these particles. So these electrons are going to try to come closer to this part, and the electrons which are over here, because of the existence of extra electron, they're going to be pushed onto the right side. So if I give you a magnified view, highly magnified view, figure not down to scale for this part of the plate, let's say this is the magnified view. So let's say this is the plate, positive plate over here. For this positive plate, most of its electrons would be located to the right side, because these electrons over here, and for this plate, the magnified view for this plate can look like that most of its electrons will also be located to the right side.
Basically induction হচ্ছে আর কি।
Exactly.
স্যার can I
হ্যাঁ বলো।
স্যার এখানে কি আসলে like is it that the charge particle is getting stored in a deformed state inside the capacitor? Or
Yes,
am I wrong?
yes, charge particle slash atom.
Like it actually reaches some kind of equilibrium inside its deformed state, right?
No, it is not in equilibrium. It is in a heightened energy form, which it wants to get rid of the first chance it gets. Equilibrium would be the left figure, where the center of the positive charge and the center of the negative charge coincide. Whenever they have a deformation, we do not define that as an equilibrium state. That is a heightened state or higher energetic state.
Yes, sir.
Sumaya, bolo.
স্যার ভিতরের যে মানে মিডিয়ামটা ওইটার উপর কি ডিপেন্ড করবে যে ক্যাপাসিটর ক্যাপাবিলিটিটা যে কত বেশি চার্জ সেটা মানে?
Beautiful question. The answer is a solid yes. I mean, what is the atomic arrangement of those particles? What is the proton number and the electron numbers of each of those atoms? How densely they are packed? All of these factors will affect the capacitance of that material. So in true case, or in practical cases, the choice of this material is based upon two things. First of all, longevity of this material over a really large number of cycles. I mean, if you continuously do this, how long should this material still be able to retain its electrostatic property? That's one factor. And the second factor is price, or how cheap that material is. For example, typical capacitors, or the circular capacitors that we see, let me show you a cross-sectional view. This might as well be a very Facebook.
স্যার ক্রস সেকশনাল ভিউ দিয়ে সার্চ দিতে পারেন।
আচ্ছা দেখতেছি। Yes. Although it's a very small image, so let me just copy this and take it up over here and zoom it out to make sense. All right. Have a look. We have two different metal heads of this capacitor, and inside this capacitor we basically have a rolled out sheet. Have a look at the different parts of this capacitor. So the brown colored thing is labeled as dielectric, which can be a piece of plastic sheet, it can be a piece of waxed paper, it can be a piece of very thin but yet flexible sort of ceramic material. Ceramic capacitors are very good. Or it can be something else which is flexible so that you can roll it out. And as a metal plate, you are using aluminum foil. So what you're doing, you're making a really large sandwich of these four materials, and then you're gonna roll it, and you're gonna connect the two plates. You're gonna connect these two connectors, one with this plate at some point of this whole thing, one with this plate at the other point. So you are basically what you're doing. You are basically introducing a really large amount of material, but by rolling it into a cylindrical shape, you're consizing the total amount of volume of that thing. এটা কি বুঝছো?
জি স্যার।
না বুঝো নাই?
স্যার বুঝছি।
I doubt that. আমি আরেকটা ভার্সন দেখাচ্ছি। মনে করো এখানে ফিল কালার দিব হচ্ছে সলিড কালার, ফিল কালার দিব হচ্ছে মনে করো হচ্ছে গ্রিন, আর বর্ডার হচ্ছে বর্ডারও মনে করো গ্রিন। মনে করো এটা হচ্ছে একটা ম্যাটেরিয়াল, ইনসুলেটর ম্যাটেরিয়াল। এটা অনেক লম্বা, ঠিক আছে, এদিকে অনেক লম্বা। তার উপরে আরেকটা মনে করো হচ্ছে মেটালিক ম্যাটেরিয়াল, তার উপরে আরেকটা ইনসুলেটর ম্যাটেরিয়াল, নো ওকে, তার উপরে আরেকটা ইনসুলেটর ম্যাটেরিয়াল, এবং তার উপরে আরেকটা মেটাল ম্যাটেরিয়াল। ঠিক আছে, এখন নরমালি তুমি চিন্তা করো, আমরা আমাদের প্র্যাকটিক্যালি এরকম চারটা দেওয়ার দরকার ছিল না। আমরা পিছনে যে ইনসুলেটর ম্যাটেরিয়ালটা সেটা যদি নাও দেই, মনে করো আমরা এখানে আমরা এই মেটাল এন্ডের সাথে একটা পজিটিভ ওয়্যার কানেক্ট করলাম, এটার সাথে একটা নেগেটিভ ওয়্যার কানেক্ট করলাম, তাহলে আমাদের এই মাঝখানে এটা কি করবে? ডাইলেকট্রিক মিডিয়াম হিসেবে কাজ করবে। প্রবলেম নাই তো? প্রবলেম আছে? দিস রেড থিংস আর টু মেটাল প্লেটস, বুঝতেছো?
জি স্যার।
এখন আমি যদি জিনিসটাকে রোল করতে চাই, তাহলে আমি আবার কি চাইবো? এইটা যাতে আবার এটার সাথে কানেক্ট না হয়, কারণ এটা যদি এর সাথে কানেক্ট মেটালিক মানে ফিজিক্যালি কানেকশন হয়ে যায়, তাহলে তো শর্ট সার্কিট হয়ে যাবে। ওই শর্ট সার্কিটটা অ্যাভয়েড করার জন্য আমি মাঝখানে আরেকটা মেটালিক প্লেয়ার দিলাম, যাতে করে আমি পুরো জিনিসটাকে সিলিন্ডারের মতো করে রোল করে ফেলতে পারি। so that I can accommodate a really large surface area of this metal piece, and that will also involve a really large area of this material, and I can introduce it into the capacitor. This allows a very high amount of capacitance for a very small size of capacitance material. Yet, if you want to make the capacitor to have even better, higher capacitance for even smaller volume, that would come to the point of the choice of this material and the choice of this material. By choosing more presence of atom for this material. For example, if you use as cellulose, paper has a certain molecular density. Okay, and then if you use, let's say, some sort of high dense plastic, for example, nylon, that has another polymeric chain structure. So the choice of material will affect how much capacitance can you give, and also the thickness as well. But there is a question: if you make this material really thick, then you cannot make too many layers. If you make it really thin, then you will be able to make it too many layers. Now, what does the thickness has to do? The thickness has to do everything with how much maximum voltage can you work with. Try to understand. If this material is really thick, then these two plates can sustain or withstand a bigger amount of voltage value. They are not going to short circuit in between. But if this insulator material is really thin, then beyond a small high voltage, they are going to be able to start short circuit or between them through the dielectric medium. So if you want the capacitor to have a really high voltage capability, then you're going to make the dielectric medium thick and vice versa.
জি স্যার, বুঝেছি।
ঠিক আছে? And another benefit of having this kind of shape is that you do not essentially have to calibrate this whole thing. You can roll this out, and you can continuously measure how much capacitance does this have, and whenever you get the expected value of capacitance definitely within some tolerances, then you can cut this whole sandwich thing and then roll it out and put it into your box, and you're done. So your production process does not have to be precise for every single component of your device.
জি স্যার, বুঝেছি। থ্যাংক ইউ।
No problem. বলুন, এই জিনিসটা বুঝে গেছে সবার কি বললাম?
জি স্যার।
This is basically what these capacitors look like, or these capacitors look like. এই যে এখানে যে খুব ভালো করে দেখানো আছে। এই যে এটা হচ্ছে অ্যাকচুয়াল ক্রস সেকশনাল ভিউ। যেটা ক্রস সেকশনের কথা বললাম না, this is the actual cross sectional view. So if you really smoothly maybe it was cut using a water jet because there is no abrasion sign, or na laser দিয়ে করলে তো melt হয়ে যাবে. It was definitely cut with a water jet. So if you do this, then you can see that all of these things, these are the aluminum plates, and the in between black things, those are the insulator material. This is the casing. এই কেসিংটা হচ্ছে কোন একটা মেটাল দেয় কার যাতে করে জিনিসটা ভচকায় না যায়, and then that basically this is basically the capacitor. So if you cut this cross sectional view, you're gonna be seeing this thing, and inside we have this thing, basic idea. আচ্ছা, আর কোনো কোশ্চেন?
স্যার একটা কোয়েশ্চেন ছিল।
বলো।
স্যার এই যে আমরা যে বলি ক্যাপাসিট্যান্স ইকুয়াল টু চার্জ পার ইউনিট ভোল্টেজ, এখন এখানে কি চার্জ বলতে are we referring to the number of charges which are undergoing the electrostatic deformation?
No, we're talking about the amount of charge measured in coulomb unit that will exist in any of the plates of the capacitor.
Because of the electrostatic deformation, right?
Yes.
But sir, physically তো কোনো current move করছে না towards the capacitor, right?
Through the capacitor কোনো current move করতেছে না, but from the capacitor, out of the capacitor, into the capacitor and out of the capacitor current flow করতেছে। মানে হচ্ছে যতক্ষণ পর্যন্ত আমাদের ক্যাপাসিটরটা পারফেক্টলি, আমি তো আগে ফিগারটা মুছে ফেললাম, আচ্ছা আমি থেকে দেখাই, পিডিএফ থেকে দেখাই, যতক্ষণ পর্যন্ত মানে as long as the equilibrium or saturation does not occur, the capacitor reaching the maximum voltage is what we call saturation. As long as the saturation does not occur, your capacitor is gonna be charging up. So if this is charging up, necessarily that would mean what? As long as the current does not become zero, there exists a current in the circuit. Current is not flowing through these two plates, but essentially this positive end is feeding current to the plate A, and this B plate is feeding current to the negative plate of the battery. That has to happen, but current is not flowing through this part.
And sir, we can say যে কারেন্টের মানে because of this difference in charge, there is মানে যে electrostatic inductionের কারণে আমার এই যে ডিফরমেশনটা হচ্ছে।
Exactly.
Sir.
Okay. It's 9:36, so I'm gonna pick up from this point next class if you kids don't have any further question. Many people have already left, I can see that. Okay, good night.
Assalamu alaikum.
Waalaikum salam.